Assalamu alaikum warahmatullahi wabarakatuh, my dear students, grade 12 students in your math course. This is your math course for SAT exam, and today, inshallah, we'll try to finish 2 lessons, and the remainder will be about 4 lessons, inshallah, tomorrow and after tomorrow we'll finish them. Okay. Today, inshallah, we'll talk about the first part or the first session. We'll talk about the geometric sequence. Geometric sequence. The geometric sequence, as we said before, it's sequence of numbers where the quotient of the dividing any term by the previous term is a constant value, which is called the common ratio. The common ratio and denoted by R. It means, for example, if I have 2, and then after that, this 2 becomes, for example, 6, and this 6 becomes, for example, 18, and this 18 becomes, for example, 54, and so on. This sequence is called geometric sequence. Why it's a geometric sequence? Because we have a common pattern. What is a common pattern or the common mechanism for the pattern? We multiply by 3. We multiply by 3. If you multiply 2 by 3, it's equal to 6. If you multiply 6 by 3, it's equal to 18. If you multiply 18 by 3, it's equal to 54. How we can get this common ratio? This is called the common ratio. R is called common ratio and denoted by R. How you get the common ratio? The common ratio is A n plus 1 over A n. Or by another words, it's the second term divided by the first term, or the third term divided by the second term, or the fourth term divided by the third term, and so on. It means if you divide 6 over 2, it means the second divided by the first, you will get 3. You will get 3. Sorry. You will get 3. Even if you divide 18 by 3 by 6, you get 3. So this is the common difference. So the way to know you have a geometric or an arithmetic sequence is to discuss the pattern or to get the common mechanism for the pattern. What about Mr. the general term an? What about the general term an? The general term an here in the geometric sequence will be a1 multiplied by r power n minus 1. A1 multiplied by r power n minus 1, where in a1 is the first term, r is a common ratio. Okay, this is the general term, or tn or an. Some books or some exams talk about tn or an. They are the same. They are the same. The first term or the nth term, and we have to denote it by an or t. About the summation. About the summation, the rule of summation, Mr. You have 2 rules for the summation: the finite geometric series or the infinite geometric series. Finite geometric sequence, Sn equals to a1. This is a1, open bracket, 1 minus r power n, and down you will have 1 minus r. This is what? This is Sn, and this is finite. For example, I ask you to get the summation of the first 15th term, S30, S15, S7, and so on. So finite. The infinite summation, the is finite summation, Sn, this is finite, and this is infinite. We have to write here a1 over 1 minus r. Only like this, yes. We have 2 types for geometric series. The The first type is called divergent, and the second type is called convergent. And this is depend on what? On R. This is depend on what? On R. R can be 3, like this example, and it can be like this. We have here 50, and then 25, and then 12.5, and so on. As you see, the number gets smaller, so R here equals to, yes, 25 over 50, the second term, over the first term, it means half. So you have two types of R. R can be between 0 and 1, and R can be greater than 1. I talk about the absolute value of R. So the absolute value of R is included between 0 and 1. It means it's greater than, it's equal to 3, equals to 4, equals to 5, equals, and so on. So greater than 1, so, or equals to 1, it's called divergent. It's called divergent. So divergent if R is greater than 1. If the absolute value of R is smaller than 1, it means, Mr., it's a half, it's 1 over 3, it's 3 over 5, so it's called convergent. Okay, and it's a very, very important part, and it's a very easy problem if he asks you about the type of the geometric series. So you just get the value of R. If R is greater than 1, so it's divergent. If R is smaller than 1, it's convergent. We'll talk about also the concept of geometric mean. The geometric mean. What is the geometric mean? The geometric mean of any two numbers, you just take the two numbers, multiply them together under square root. Again, Mr., if I have two numbers, the first number is n, and the second number is m. I need to find the geometric mean. I need to find the geometric mean of these two numbers. Just write here square root of n multiply m. So n multiply m under square root, and don't forget it's a positive or negative. Maybe positive, maybe negative. This is what we know as the geometric mean. Let's go to the problems directly. So we have here Tn or An equal A1 R n power n minus 1. Sn for the finite equal A1 open bracket 1 minus R power n over 1 minus R. Sn for the infinite or infinite series A1 over 1 minus R. And the geometric mean is the square root of the product of the two numbers. Don't forget positive or negative. We're going to the problems. We're going to the problems directly. We're going to the problems directly. Okay, the first problem. In the first problem, he asked you to find the sixth term of this sequence. Find the sixth term of this sequence. First, if you have a sequence in the exam, you must determine the sequence is geometric or arithmetic. So the first step, if you have a problem like this, okay, we just get the value of R. We have here 2 becomes 4, so you add 2 or multiply by 2. And the 4 becomes 8, no, so you multiply by 2. So multiply here by 2 equals 4, multiply here by 2 equals 8, multiply here by 2 equals 16, and so on. Okay, so you must multiply by 2. So our R here in number one, R is equal to 2. So from the beginning, R equal to 2, it's divergent. Okay. Series, the number one. Number two, if we have to get A1 or the first term, it will be equals to 2. يبقى أول حاجة يا أولاد لما بنشتغل على حاجة زي كده أعرف إن هي جيومتريك ولا أرثماتيك. After that بعد كده على طول انا عرفت انها جيومتريك، طلعت الار وطلعت الاي 1. انت محتاج ال6 تيرم، اقول له حاضر على طول. الرول بتاعي ايكوال اي ان اللي هو هيبقى اي 6 equals to A1 multiply by R n minus 1. After that, substitute directly. A1 is equal to 2 multiplied by r is equal also to 2. N minus 1, you get 6. So it's 6 minus 1. So it will be 2 multiply 2 power 5. So, Mr. 2 power 5 equals 32. 32 times 2 equal to 64. Equals to 64. So the answer will be letter A. The answer will be letter A. So we get the type of the sequence. After we get the type, we get the two properties, which are, or the two requirement, which are R and A1. And then after that, write the rule, substitute, and to get the answer. We go on to number 2. Number 2, the positive geometric mean of the two numbers 12 and 3. As we said, to get the geometric mean, it's a very easy problem. It's a positive or negative square root of the product of the two numbers, which is 12 multiply 3. Mr. In the problem, he said the positive geometric mean. So we take the positive value also. Okay. So we get the square root of 36. Square root of 36 is 6, and we get the positive value also as he said at the beginning of the problem. So the answer is 6. So just substitute and get the answer in about 5 seconds. We're going to number 3. Find the sum of the infinite geometric sequence. Oh, infinite. So infinity, mister. So S infinity. S infinity equals 2. I write the rule. A1 over 1 minus R. Okay. So I need A1. Whose first term is 15? Oh, A1 is equal to 15. So A1 here equals to 15. So I just write here 15 over 1 minus R. And the common ratio, which is R, is 0.5. So it's a direct problem. Just I need to calculate it directly and find the result. So 15 and 1 minus 15 is equal to 0.5. So 15 over 0.5, it means 15 multiplied by 2, it means it's equal to 30. You get the answer. Okay. So if you have a problem like this, it's very easy just if you know the rule. If you don't know the rule, it's a big problem. It's a big problem. مش حافظ القانون او حصلت لخبطه في القوانين هتبقى مشكله يا جماعه. فبالتالي من الافضل ان انا اجمع القوانين بتاعتي كلها في 2 او 3 بيبرز A4 خلاص، وتبقى القوانين موجوده عندي اراجع عليها او اشتغل منها، حتى لو انا هرجع للمرجع بتاعي او الريفرنس بتاعي اللي هو الورق ده. تمام. الورق اللي هو الاي 4 ده يا جماعه اللي انا مجمع فيه القوانين، سواء كانت جيومتري او الجبرا او statistics او لو رجعت للورق ده دلوقتي ما عندكش مشكله ترجع له، ولكن هتلاقي عندك في الاختبار ان انت حفظته اوتوماتيك بتقدر تشتغل عليه. طيب اوكي، نيجي بعد كده نمبر 4. find the common ratio. find the common ratio. So R is missing. I need to find R. R is missing of the geometric sequence that its sixth term is okay. He gave me A6 equals 2, so this is the value of A6. A6 is equal to 243. And the third term is 9, so A3 equals to 9. A3 is equal to 9. So, Mr. You have the sixth term and the third term, and we need to find the common ratio. I think we talked about a problem like this in the previous lesson, as we will make two equations. هنحل two equations مع بعض يا جماعة. هنحل two equations مع بعض. طب انت قلت لي ال A3 equals ايه؟ انا هفتكر على طول ان ال A3 يا جماعة، ال A3 كان ليها رول، هي ال A1 multiplied by R power n minus 1. N here is 3, so 3 minus 1 is 2. And you give me the value of A3 as 9. And then you have A6. A6 equals to A1. And here you have R power 5, excellent, equals 243. Now you have the two equations. I'll solve the two equations together. How you'll solve them together? I'll divide them. I'll divide A6 by A3. So A6 divided by A3. Substitute. So, Mr. It's equal to A1 R power 5 over A1 R power 2, which equal to 243 over 9. Cancel, mister. I'll cancel here A1 with A1. So the remainder R power 5 over R power 2 minus the powers excellent, it will be R power 3. R power 3 equals 243 divided by 243 divided by 9. It's equal to 27 because you have to get 3 power 5 over 3 power 2. This is 3 power 5. If you remember from النجات القدرات, this is 3 power 5 and this is 3 power 2. If you subtract, it will be 3 power 3. It means 27. Mr. Under cube root, it will be 3. Yes, under cube root, it will be equals to 3. So you have R equals 3. R equals to 3, and we get the result. So if you have a problem like this, just write the equation of the first requirement, the equation of the second requirement, divide them together, and get the answer as you see. We're going to number 5. In number 5. In number 5. In number 5, he said, find the sum of the first 8 terms in this sequence. Find the sum. The sum, it means summation. Of the what? First 8 terms. It means I need S8. So it's finite. It's finite. I stop at the 8th term. So, mister, I just write the rule. So Sn equal, mister, A1 open bracket 1 minus R power n over R 1 minus R. So, mister, you need Sn. So S8. So S8 equal to A1. First term here, this is A1. A1 is equal to 3. So, mister, it's 3. Open bracket 1 minus R. Oh, R equals to what, mister? 6 divided by 3 equals 2. Or 12 divided by 6, also it's 2. So, mister, it's 2. 2 power n means, mister, 2 power 8 over 1 minus R, it means 1 minus 2. Calculate. You have here -1, so the result will be negative as you see, because you have negative down, and 3 multiplied by 2 power 8, 2 power 8 multiply, 1 minus 2 power 8. 2 power 8, 2 power 8 equal to 256. 256, 1 minus 256, it will be negative 255. So it's calculation. It's a calculation. Negative divided by negative, it's equal to positive. So the result, mister, 3 multiplied by 255. Again, it's a quick calculation. We have 2 power 8, 2 power 8 is 256. You must know the 2's till 2 power 10. Till 2 power 10. If I ask you 2 power 5, for example, it's 32. 2 power 7, it's 128. And also 3. 3 till 3 power 5. If I ask you 3 power 4, 81. 3 power 5, 243, and so on. This will be like a quick calculation and save the time. And this is from GAT. You must know it. Just need to multiply 3 times 255. 3 times 200 is to get 600, and 3 times 55 is 165. So 765 if you add and get the result quickly. So the result is letter B, which is 765. Okay. This is the result for number 5. We're going to number 6. Pay attention with me in number 6. In number 6, I need the infinite or finite the geometric series. Infinite geometric series, mister. So the rule. So I just write the rule. So Sn equals 2. A1 over 1 minus R. A1 is what? Pay attention with me, please. He said here from n equal 1 to n equal infinity. It means the infinite. So n1, I get n equals to 1, so I substitute by 1 here. So, mister, I just write multiply 3, multiply by 1 over 4, multiply by, and here power, 1 minus 1. From where you get 1? The first term. The first term. So it's quarter power 0, and any number with power 0 is equal to 1. So the first term is 3. The first term is 3. So Mr. A1 is equal to 3 over. I have here to write 1 minus R. R is what? R is a quarter. Because in this form, this represents the first term. So 3 is the first term. And this represent R. So this is R. So R here equal to quarter. So I just write quarter. Just substitute and get the calculation. You have here 3 and you have here 3 over 4. From where you get 3 over 4, 1 minus quarter equals 3 quarters. Get 4 up by multiplying, mister. So it will be 3 multiplied by 4 over 3. Cancel 3 with 3. So the result will be 4. And the result will be 4. The result will be 4. So the result will be 4, Mr. Letter A. The sum equals to 4. And it's convergent. Yes, it's convergent because the value of R is less than 1. It's quarter. It's quarter. So it's convergent from the beginning. We can ignore this. So it's convergent and the result will be 4 as we get. Okay. So this is number 6. We're going to number 7. We're going to number 7. In number 7. Number 7. The nth term or the general term for this sequence. It's very easy. The rule of the general term, you said, Mr. The rule of the general term, an equal a1 r n minus 1. I get here, so 16 divided by 2. So, Mr. A1 is equal to 2 and R is equal to 8. Okay, because you divide 16 by 2, you get 8. Just substitute, mister. So the nth term, so an equal a1, mister, is 2. And we have R equals to 8. So just write 8 and n minus 1. Leave n minus 1 as it is, as he get here the nth term, or don't give me the value of the sequence. So I just write n, 2 multiply n, so it's letter C as you see. Letter C as you see. Pay attention about a very important remark. We can't multiply 2 by 8. We can't multiply 2 by 8. If you multiply 2 by 8, you get 16 power n minus 1 as letter D is wrong. Because the powers here is different. So we can't multiply. Okay, pay attention about this remark, please. It's very easy as you see, but some of my dear students complete the problem as 2 multiplied by 8 equals to 16 and write it as letter D. It's wrong. It's wrong. Okay? Okay. Find the common ratio of this sequence. Find the common ratio of this sequence, number 8. Number 8, the common ratio, it means I need to find R. R here is missing. To find the common ratio, mister, just divide the second term by the first term, or the third term by the second term. So it's really easy, mister. So 6 over 15, the second term, divided by 2 over 3. Mister, we don't have to divide, you need to multiply. So 6 over 15 multiply 3 over 2. Just mentor cancel, divide by 2 equal 1, divide by 2 equals to 3, divide by 3 equals to 1, divide by 3 equals to 5. So the result, as you see, it's equal to 3 over 5. So 3 over 5 is the answer, and it's convergent also. Convergent because the value of the R, yes, it's less than 1. So the answer here is 8. The answer here is 8. Yeah, sorry, the answer here for letter 8 is D. We're going to number 9. The common ratio are in the convergent. Oh, I'll talk about this. It's a very easy. Convergent. Convergent is what? Is less than. So R is less than convergent. R is less than the value of 1. And this is just a direct problem. So 1 or 2 or 3 seconds by getting the click or getting the answer. Okay. We're going to number 10, the last problem with us in this part. We have in a geometric sequence R equals 2, and A equals 10. A1 equals 10, I need A5. So A5, we have the rule here. The same rule. Just substitute. So A5 equals A1. A1, mister, is equal to 10. Multiply by R, Power n minus 1, it means R power 4. R here is 2, so I just write 10 multiplied by 2 power 4. You can't multiply 10 and 2. Finish the power first. By the order of mathematical operation, as we said before. It's equal to 16, so it's 10 multiplied by 16. It's equal to 160. So the result will be letter C, which is 160 as you see. This is the first part, and this is the end of the lesson for the geometric sequence and geometric series. We have the rules for the general term. We have the rules for the geometric mean. Also the summation for finite and infinity. And also the type of the geometric series, which is divergent and convergent as we see. Thanks, my dear students, and see you.